probably start with all the disclaimers. Alright, what we got here is I got two Volvo calipers. Okay, these are both loaded calipers. There's the part numbers. They were ordered through Rock Auto, I believe. These are John's calipers. Basically what it comes down to is we've looked all over the place and haven't found anybody. Well, let's one thing at a time. Anyway, I'm only going to work on one here to start with. Let's put the other one away. Alright, I'm not sure which side this is. Doesn't really matter. Okay, this is a Volvo caliper. A 4-piston caliper. Comes with the little copper washers. Don't have any need for those right now. What this is for the Roadster. These calipers are very popular. They come off a 240 series, 245, stuff like that. And I've seen a lot of information online where these are used on a lot of different cars. I mean, everything from you know, old Datsuns, old MGs, some other cars I didn't even recognize the name on and that stuff. They use them on the Roadsters quite a bit because these two holes line up. And so then the Roadster disc brake kit has a spacer to center these over the rotor and that stuff. And anyway, these are for the well, these are for the non-vented rotor. So I sure hope that's what he wanted. Because I'm going to be drilling them and modifying them anyway. So yeah, let's hope like heck they're exactly what he wants. Anyway, the gist of what we're doing today, the Volvo calipers. See how they got two ports here? Okay, the Volvo uses two separate brake systems on the same car. Okay, so if one system leaks and gets you know, and starts to fail, the other one will still work. Okay, so now you can get a manifold from Breck Myers. Look him up, Google him, whatever. Anyway, he sells a brass manifold that you can bolt down on here. Challenge sometimes is these surfaces aren't always machined on all the calipers. Not exactly sure why. We haven't been able to figure out any predictable way to, you know, determine which one to order to get the machine surface. Anyway, he has manifold, and it takes those two lines and puts them into one brake line. Okay, you can also do two brake lines out to a T-fitting kind of thing and hodgepodge some stuff together. So this is a fairly common mod. What we're going to do is we're going to go inside and cross drill between two of the pistons so that fluid goes all the way. They're no longer separate systems. Okay, and then one hole can get plugged and the other one can get used. So we're gonna research that. There is a write-up by one person, a few pictures, stuff like that. It's the go-to reference kind of thing right now, but I haven't been able to find any videos or anything like that. So there's a bunch of people that say, you know, absolutely do not pop these bolts and split these halves. There's a bunch of others that say, hey, they do it all the time, no big deal. You know, there's kits out there for certain calipers and that stuff where you split it apart and you can put a spacer in here so you can change how wide it is for the rotor you're putting in. You know, you could literally convert this to for a vented rotor. No point in doing that because, you know, hey, the calipers for the vented rotors are quite readily available. So we're going to be breaking this thing apart and learning as we go because I haven't done this before either. So basically all the disclaimers. As far as I'm concerned, this is going on the shelf. This is going on a vehicle that will never be driven. It's a static display vehicle. You know, it'll just have one hose to make it look nicer. Whatever. All the responsibility of everything past this point, you know, leaks, all that kind of stuff, anything. That's all on the owner of the calipers. So let's start looking at it here. Now this is a fully loaded set. Fully loaded means that it comes with all the hardware and the brake pads. Semi-loaded means that it comes with the hardware, no pads. And then an unloaded set, it's just the bare caliper, no pins, no anything else. Okay. So I'm not exactly sure yet if the if the brake shoes are the same on both sides. They kind of look like they are. So we'll pull out the 2 hairpins there. That one's a little loose. I'll probably pinch that one together some more. And we'll pop that out. Those 2 springs come out. The other pin comes out. All right, now this stuff's all, there's no left or right to that. That's the same. So let's see here. This is the outside. This is the inside. I think the pads are identical. Hey, they got my initials on it. MK. That's funny. Now it says me. M-E. FM2110FF. The other's probably a batch number. So anyway, they look to be the same. They look to be identical. So I'm not going to worry about them. So let's see, what do we got next here? You can see the pistons down inside there. Now, what we're going to do is we got to get in there to drill in the bottom of the piston, so we need to break it apart. There's no way to... Man, you can almost get a really long drill bit in there and do it without splitting it, but you still got to get the pistons out. Easiest way probably to get the pistons out is to use compressed air and blow them out, which we may end up doing. We may just try to get them out with the 2 screwdriver method. I'm going to try as best I can to... now these may require an adapter. These, now that I'm looking in here, let me, I'll shut it off and get another view here. All right, that's looking down in. Okay, that is not a double inverted flare. Okay, that looks to be more like a bubble flare. So it may require an adapter. You may not, you'll have to look and figure out what kind of hose goes on there and that stuff. Not my, not the scope of what I'm trying to do today. So I'm really not too worried about it. You might use the fitting on there with a banjo bolt, and then it really wouldn't matter. Well, I'll try to remember to keep it in the frame here. So let's take a peek real quick at. Okay, that's just the dust seal basically. I've put down a new piece of paper here. I want to try to make sure you keep all this stuff just as clean as possible. And then wipe it down again before you put it back in. So some, let's see, I don't know if you can see there, some calipers there's a lip right there, and some caliper pistons, and you can pick that up with 2, but it doesn't look like that's going to work on this one. That's just the dust seal. You still don't want to, you know, mar it up and score it up a whole lot or anything like that. I took the plugs out of here because I want air to be able to come out, you know, if I try to lift that up. So we'll try it gently here with a couple of screwdrivers, and if it moves and comes easy, we'll keep going. But nope. All right, let's. I've got air, so we'll just use air. So I'm kind of thinking that I went and got a block of wood to put in there, so when the pistons blow out, they don't smack each other and stuff like that real hard. Anyway, if I blow into this circuit basically has fluid passage up through here over to this one, okay? They're isolated this way, so then I got to blow into here to do that one. If I break these halves apart first, this one's going to have 2 holes in it, and I might have trouble blowing the piston out. So I think we'll give it a little air and see how it goes. We'll take this dust seal off. Okay. Now I got a rubber tip on here to seal, so, oh, doesn't quite, but, well, let's put it down there at an angle, maybe you can see it better. Now I'm going to try to feather this real slow. All right. You like that? That took a bit of control. Okay, so let me let's get a Sharpie here. So I'm going to put some Sharpie marks on here, and because I want to make sure they go back in the same holes basically. So let's call this one 1, this one 2, and I'm going to write 2 in the bottom of the thing there. I'm going to put a 1 there. Let's just put it right here. 3, 4. And I might not be able to, so I'm going to just put 3 lines on it for now, because I might not be able to get in there and draw, write the number in there first. So I'm not too worried about getting that side off, because quite honestly, everything I've read so far, I've not seen anything that said drill both sides. Okay, and now that I remember that, I can put the dust seal back on there. When I split this, I'm just going to drill this side. That'll make both chambers, fluid will go both directions, everything will be fine. So I don't even want to break this side apart. Okay, you will see that online where people tear them down completely, but it's usually old calipers they're cleaning up. They need to put in new seals and everything like that. No reason to do that to this half. One thing I will look at though is when I get down in there, I want to see how this bleeder valve works. If the bleeder valve goes to both, yeah, I want to see how that goes. That will determine whether or not I take this side apart and drill between those. You know, because there's another bleeder valve here, so that's the top of the piston. So I think these bleeder valves are to bleed the bottom circuit, and that one's to bleed the top. So anyway, first one's out. Let's take the second one out. I'm not too worried about the dust seals matching up. That's a little too yeah, just not necessary. Okay, so and this has got lube on it. When we put it back together, we're going to put it back together with brake fluid, because that's what's going to happen it anyway, and that's the equivalent most likely of brake fluid anyway. So let's put our block back in here again. Try to get a seal, see if we can feather this again and get it to come out as nice as that other one. Ah! Wrong side. So I'll check and make sure that dust seal goes back in there. Same as the other one, but I think I'll modify this a little bit. Okay. Doesn't need a huge amount of pressure there. I don't want to clamp it down too hard, but I do want to hold it back some so that this one comes out first. That's a better. And you wouldn't want your fingers in there. Of course, that's just cedar. That's pretty lightweight, soft wood, but still, you heard the pop. Okay. That's from number one. I think we're on to breaking the caliper in half. Now what I'm going to do here is, if I go on this side and try to break this loose, that leverages everything on this fulcrum point here, and I got to try to put equal load here and here. But if I come over here to this one first, okay, then the fulcrum point's way back here, which, you know, gives me a whole lot more leverage. So, as much information as I could find, these are not torque to yield bolts, which means that make them a one-time use bolt. Well, heck, I guess I'm going to have to do this one from this side, aren't I? Oh. And they're the only torque specs I could find was somewhere in the 30 to 50 range, so I'll go over some of that a little bit later too. So yeah, that looks like just a standard bolt. Nidloy, something like that. Anyway, I'll measure these and find out what size they are. If you're dealing with old ones and trying to rebuild them, you may end up having some rusty ones, broken ones, whatever. So we'll see if we can remember to get the sizes on that too. So. Oh, maybe. Ha 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 ha. Don't have to be too bright to be me. Put it down a little bit more though. Alright, let's try that. There we go. And, you know, on the next one, this is all for sake of demonstration for those guys who just don't have access to all the toys and that stuff. I've got impact, electric, and air, and all that stuff, so I guarantee you on the next one, I'll just be doing that. But if I can, I'll tend to show the cheapest, simplest way, because, you know, most guys don't have, a lot of guys don't have access. You know, if you're playing with cars and stuff like that, then you got to have a buddy with air and stuff like that. So some of the Nissan calipers, the single piston calipers, you know, the banjo bolt bolts right on the back, and you can literally take that out and just, you know, push a wooden dowel in there to take the piston out. Okay, so there's the O-rings, and what I'm going to do is I'm going to, since I don't think I'm going to need to do anything to this side, I'm going to take this and cover it, and I'm going to move it off the bench. Alright, hopefully you can see down inside the hole there. Not positive there's enough light. Okay, that's where the bleeder hole goes. So this bleeder valve is for the top circuit, okay, and the fluid goes in this channel here, up through the that hole, okay, which that goes out to the bleeder valve and over to the other half, okay. Now there's a hole here in this side, and that comes to this port, okay. This port goes to a hole right there, so basically they just drill straight through there. So what you're trying to do is you're basically looking to just connect this hole with another hole on the other side. Now, one thing that I did notice that was brought up online was you don't want to drill down too far, or you're going to poke through the backside here. Really don't want to do that. So we're going to take a couple measurements so that we have an idea of just how thick that is, and get a better idea. And they suggested using a bigger bit, basically. I would say that you could use a bit up to the size of that hole. And it looks like the other hole coming in is the same size as the Bleeder valve. Oh, yeah. So, your bridge... So let's see here. You have... you have your bores like this. You have a bleeder valve right here. Is that in the picture? Nope. So anyway, you have your bores. There's the bleeder valve hole going in. The one that's down inside there, if you can't see it real well, basically comes in like this. Okay? And it just nips that hole. It doesn't cover the whole thing or anything like that. It nips that hole, and it's this opening right here. So we're looking to do the same thing on this side. Okay, so we really don't have to you know, that's how thick the caliper wall is, let's say. We really don't need to drill too deep down in here. So you really only need to drill one side. Okay, so let's find a drill bit that's the size we want. Okay, that's 5/16. That fits pretty well. And 5/16 is a real common size one to get. So now, basically, we're going to have to try to get drilling down in there at that angle. That might be a bit of a challenge, holding it in that one spot. Since it's hitting out here on the edge of the drill bit, drilling a pilot hole is really not going to help me a great deal. Okay, because that's where it's going to be catching and walking me all over the place and stuff. So, the other question is too, is being able to grab it back here with the drill chuck and be able to put it in there with a drill bit this short. So, you know, you go in at an angle like that, we're not going to hit the hole as easily as if we can run in at that angle there. You know, and I think I might just use a smaller drill bit for the fact that what's happening is one edge, the drill bit is almost all the way out at the edge of this machine surface here. So I want it to bite fairly evenly. So I think I'm going to get a smaller drill bit so I can be on that shelf and not out here at the edge. Now I could cheat a little bit. You know, I've got these drill bits from Boeing that are a good bit longer, and if I was just doing this for myself, you know, I just use one of these because, you know, man, a whole lot easier to get in there. But that doesn't help the guy who doesn't have those. So let's do a 1/4 inch. Okay, now the challenge with 1/4 inch is we lose more shank there. So another option that, do I have it in here? Yes, I do. Another option is, now this a 5/16? Yeah, it's a 5/16. Okay. Let me zoom that out a bit. So this is a long drill bit picked up at Home Depot. They don't cost that much or anything like that. They're for, I bought it to, you know, be able to run a coax cable, you know, through some headers and stuff like that. You know, so I couldn't get to the backside or whatever, so I wanted to be able to drill through. So I could quite easily get in there with that. But we'll try it with a 1/4 inch first, since most people will have access to that. Then I got two other concerns here too. In drilling down in the hole here, the chips I create, stuff like that, I definitely want to be able to blow this all out and clean it all up and everything like that. but I have these two square shouldered seals in here. So then the question becomes, do I pull that out just to make sure that I don't get any little chips stuck in it or anything like that? And I certainly wouldn't want the drill bit to catch and tear it. So this is for number 1. So I'm going to set it with piston number 1 over there. Alright, and you see, I think you can probably see how I did that. This is just cheap Harbor Freight scribe, you know. It comes to a very sharp point, so don't poke it into the seal, but I'm going right into the gap there. You know, and I'm working it back against the hard shoulder. So that way I can kind of push it out without causing any scraping, scratching, or anything on the seal itself. Drilling in there, you know, don't slip off, poke your hand, and all that kind of crap. And if you do, hey, I'm sorry, but you know, it's on you. That's nice and soft. Okay, and if I angle over here just a little bit more, I get a little more clearance to go down in there. So let's see if that gets us our distance. No hole yet. Oh, and the other thing I did to get a little extra room here. Okay, this is a nitride coated. I don't have a whole lot sticking in there. Okay. Now that's not real good. This isn't a high torque thing. This would spin in steel or something like that. But I wasn't too worried about that. But it may tend to make it wobble a little more too. Yeah, it looks like we're gonna make contact, but you know, if it needed to be close to 1/4 inch deep, then you know, we're only about halfway. So something I'll try to get over that way a little bit more on the next one, so that way when it walks it comes more in line. It's pretty darn close, and I may go and I may move up to the bigger drill bit, because then that way the top part here, the wall, will cut and hopefully come in closer. That way I don't have to go deeper. I just need it to come up. You know, so instead of going deeper here trying to catch, you know, the bottom there, if I get it up here, it'll should cross paths with that hole more. So okay, kind of at a angle there, so not the best measurement. Okay, but that's about where the bottom of the drilled hole is. Okay, so I want to compare that with that is 1, 2, 1, 2, 3, 3. Okay. So then let's ow. So then we want to run this up to okay, that's how deep it is from there. So that's 1.533, and I had 1.233. So it looks like I've got 3/100ths to play with. Oh, yeah, out of the picture there, aren't I? So anyway, 300,000. So I definitely don't want to push that limit too much. let's yeah, I'm at 127, so I'm a hair deeper already than I was by about 10, 20, 30, 40, about 40 thousandths. So I definitely want to try to keep that up higher on the next one, and then it would hit more easily. So let's see the 5/16. It may not like this at all with having it pre-drilled with the quarter. This one's long enough and has enough clearance that it'll hit the edge of the bore there. So try not to do that. Whoop. And there we just saw the chuck slip. Okay, I'm bottomed out with the 1/4-inch hole, and I'm still not seeing, there's that, I'm still not seeing any indication of a hole there. Yeah, I definitely see it there. Yeah, so basically I need it to come up more. Let's try something else. Well, I think on this one, I am going to cheat a little bit. Use the long one here. And we'll try a little harder on the next one to get it at the angle we want. But there we go. Now I'm starting to get a little punch through. I'm drilling at the top edge of the hole there. And since I have just shank here, I can rub a little bit on there and not worry about grinding away on the bore. All right, we got a good hole there. That's looks to be at least 1/8 of an inch, whatever that tip is. Let's see if we can get you a good eyeball on the holes there. Okay, now this is the original one. Okay, I drilled up in the you know, up toward the top there. Basically, I held the drill in there and went through at the top there to do that. That way I didn't have to cut any deeper into the thickness, and I did that with a long drill bit, so I'll try it next time with the regular drill bit again. And if that works and everything, I may not show the trials and tribulations of this one, because it'll make one long ass video. Okay, so here's the other one. So you can see I have the 5/16 hole in there, and then I went in with the long bit and connected. So I don't know if you'll be able to see in there now, but you can see daylight coming through there. I should be able to see, yeah, you can see some light there too. Okay, so these holes, if you're curious, that goes right through at an angle down to there. you know, because you figure they can't drill in and then drill over, so they've got to pick an angle. That's part of the design thing. They got to pick an angle. Same thing with the oiling galleries in your engine block, that kind of stuff. Pick an angle that'll meet, you know. So anyway, that's all the holes. Now with hydraulics, and I'm not an expert, so you know, this is just my understanding. Don't take this as gospel or spread it around that I said this. Most people will laugh at you. Anyway, with hydraulics, okay, so we're going to have, let's see, here's the bleeder valve, that's the top, okay? So, on the other half, the bleeder valve is connected to the bottom circuit, okay, and that's how the air gets out of that, just like this one was connected to the, I better check that, I'm pretty sure though, but that way the air gets out of there, because then this bleeder valve up here, okay, that'll let air escape out of this side and this side. So that one handles the top two pistons, and then you have the two on either side here for the bottom two pistons. Okay, that was my only concern with the possibility of drilling the other side, was for bleeding. But if the bleeder valve does in fact go to the bottom piston, which I'll double check, it's not an issue. So when the pressure comes in, okay, via either hole, and everything is solid with fluid, no air, okay, as soon as the pressure pushes in on this piston, that pressure is going to equalize to this piston, through this hole, to the bottom piston over here, through this hole, to the upper piston over here, and everything will press nice and even. It's one of the things with the hydraulics. We're not worried about flow. It's not how fast the fluid moves around in there, it's how much pressure there is. So so that ought to make a nice clean thing. So let's check a couple things on the other one and see if we can't put it back together.